Okay, so as in the last video, we have discussed about the mathematical form of our consideration, right? We initially considered three capacitors and we named them as C1, C2 and C3, and we make them connected in series, and series was nothing but it was the closed path, right? We made them connected in a series, not closed path, however same path, right? So we made them connected in a same path across positive and negative terminal of the battery of potential difference provided V volt, right? Then we were known that the potential difference across any member of the capacitor. We were having three capacitor, right? So potential difference across any member of the capacitor would be different. They would gonna store the different potential difference. However, the charges stored on the plate of the capacitor would be same, right? So means they're gonna store the same charges, however they're gonna get the different potential. So according to this equation, we were initially known that Q means the charge stored on the plate of the plate of the capacitor would be directly proportional to the potential difference provided to it, right? When we remove this proportionality sign, we got is equal to C, and C we were known this is the capacitance of capacitor, right, which was the ratio between charge of the plate and the potential difference. So now we need to get the potential difference. Since potential difference would be different at each member of the capacitor, however there would be same charges, which mean we are driving this equation for the V for the potential difference, right? So C is multiplying with V here. When we go there, it will be divided. So V is equal to Q per unit C, right? So if then we talked, if we want to find the potential difference of the first capacitor, we need to take there the first capacitor, which means V1 is equal to same charge stored on the plate, so no need to write Q1, Q2, Q3, since all the capacitors would gonna store the same charges on it, right? So Q upon C1, because we are finding the potential difference for the C1. Then V2 is equal to Q, again Q is same, right? Charge is same on each plate of the capacitor, and C2 since we are finding the potential difference of the capacitor number 2. Then V3 is equal to charge per unit C3, charge again same, and we are finding the potential difference for the capacitor number 3, that's why we have taken as C3, right? Then I talked if we want to find the total potential difference on each plate of the capacitor, what would be that, right? So now see, we have already find V1, V2, V3, right? So V1, V2, V3, when we're gonna add these all, we're gonna get the total potential difference, right? So now basically I need to give you guys the concept of equivalent capacitor here, right? Now equivalent capacitor is nothing, then we're gonna continue this equation now. So equivalent capacitor is nothing, right? If we replace, if we are replacing these three capacitors, right, by a single capacitor, right? This is called equivalent capacitor. This is called equivalent capacitor. Alright, which is denoted by CE since it is equivalent capacitor, which acquire same charges, because we have already discussed that, right? They're gonna store the same charges plus same potential difference, right? Because now we have replaced all those capacitor with a single capacitor. Difference, right? Now see, if we replace all these three capacitors by a single capacitor called CE or equivalent capacitor, which will gonna store the same potential difference, right? So wait, let me make the diagram of it. For suppose this is CE, which we have replaced on the positions of C1, C2 and C3, right? And this is connected with the positive and negative terminal of the battery, provided potential difference V volt across the conductor, right? This is positive terminal, this is negative terminal, right? Positive terminal, and this is negative terminal, and here we have provided potential difference V volt, right? So how we're gonna write now potential difference, since they're gonna store the same charges and same potential difference as well, because we have replaced all those capacitors with an equivalent capacitor. So our V would be equal to Q, right? Q per unit CE. Now did you get? Q means the charges would be same, and capacitors we have already replaced by the equivalent capacitor, right? Because CE, right? Now we have derived this equation too. This is our main equation. All right? So now again using this equation, right? We know that Vt, you can say that this is Vt, right? So Vt is equal to, now we have found this is Qe, right? Initially let me write that equation first. So Vt was equal to V1 plus V2 plus V3, right? Vt means our total potential difference would be equal to V1, the potential difference which will be stored by the first capacitor, then V2, which means the potential difference which would be stored by the second capacitor, then V3, which means the potential difference which will be stored by the third capacitor, right? Providing the value of V1, V2, V3, we are replacing those all values in this equation, right? So we have already now found out our Vt value. This is Q by CE, right? V1, V2, V3 we have already found. So V1 is equal to Q upon C1, Q over C1, right? Now we have V2. V2 is equal to Q per unit C2. So Q per unit C2. Again, V3 is equal to Q per unit C3. Q per unit C3. Right, now we have placed the values of it. Now see, charge is same on the each plate of the capacitor, so we can actually take charge as common, right? So here we are going to take the charge as common. Q per unit CE, charge common, right? So 1 upon C1 plus 1 upon C2 plus 1 upon C3, since charge has been taken as common, right? Now see, charge is cancelled with this charge. So 1 upon CE is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. 1 upon C3. Alright, which means how we're gonna get our equivalent capacitor. This equation or this combination basically shows that the reciprocal of the equivalent capacitance is equal to the sum of reciprocal of individual capacitors when they are connected in a series, right? Again, what I just told now, this combination shows that the reciprocal of equivalent capacitance, this is a reciprocal, right? The reciprocal of equivalent capacitance is equal to the sum of reciprocal of individual capacitors when they are connected in series. Which means if the examiner is asking you to find the equivalent capacitors in the series, what you need to do is you need to add or you need to take the sum of all the reciprocals of individual capacitors, right? So here basically our capacitors in series or series combination completes. In the next video or from the next video, we're going to start our parallel combination or capacitors in parallel.